Now we are in the fifth video explaining this slides about functions as relations. This video we explain what we mean by identical functions. So we say two functions f and g are equal if they are equal as sets. We know that f and g is a relation, so the elements in these relations are pairs. We say that these two functions are equal if the elements inside each of them are the same. We have a theorem which says that two functions f and g are equal, which means that they are equal as sets if and only if it satisfies two conditions. The first, when the domain of the two functions are equal, and the second condition is if I take x in the domain of f, which means that also x will be in the domain of g by the first condition, then the image of this element x is the same. So for all elements x, the image under the function f and the image under the function g are equal. Since the theorem here is if and only if, this means we can take these two conditions as a definition for two functions to be equal. So we need the domain to be the same, and for any element x in the domain, the image of this element have to be equal for the two functions. How to prove this theorem? Let's prove one direction. Let's assume that the condition 1 and 2 are true for these two functions. Then we want to find that these two functions are equal as sets. So I will suppose I have a pair xy in f. This means x is in the domain of f, but the domain of f is the same as the domain of g, so x is in the domain of g, and this one is from the first assumption. Then y is equal to f of x, but we know that from the second condition, we know that f of x is equal to g of x. Hence, x and y is in g, which means that the relation f, or the function f, is a subset of g. Similarly, I can prove that g is a subset of f, and hence we can conclude that f is equal to g. Thus, assuming the two conditions 1 and 2, I can prove that these two functions are equal as sets. Let's prove the other directions, and we assume that f is equal to g as sets. I want to prove that these two conditions 1 and 2 are satisfied. So to prove one, we take x as an element in the domain of f. Then, since it is in the domain, that means x and y belongs to f for some element y. But then this x and y will be also in g, because by assumption f is equal to g, and hence x belongs to the domain of g. This shows that the domain of f is a subset of the domain of g. In the same steps, we can show that the domain of g is a subset of the domain of f using the same steps. It's just I take in this time x in the domain of g, and this means what? It means that the domain of f is equal to the domain of G. So the first condition is satisfied. Now for the second condition, suppose that X is in the domain of F again, then X and Y belongs to F, hence X and Y also belongs to G, and so since they are functions, this means Y is equal to F of X and Y is equal to G of X. So F of X is equal to G of X. From this discussion, I think it is easy for you to write the proof. So I will leave it for you to write the proof. Now we take an example. I define two functions here. The function f of x is defined as a rational function is equal to x squared plus 5x plus 6 over x plus 2. And the function g of x is equal to x plus 3. We know that when x doesn't equal to minus 2, this function f of x is equal to x plus 2 multiplied with x plus 3 over x plus 2. And so I can cancel, it will give me x plus 3. So it looks like the function f of x is the same as the function g of x, but only when x doesn't equal to minus 2. But these functions are not the same. These functions are not equal because the domain of my function f is all real numbers except minus 2, but the domain of the function g is all the real numbers. That two functions have to be equal if the domain of the two functions are equal. So since the domain is not equal, these two functions are not the same. We cannot say that the function f is equal to the function g. However, if we redefine these both functions to be defined from the domain from 0 to infinity, so minus 2 is not included, this function will be equal because they will have the same domain, and for each element in this domain, a, in the integral from 0 to infinity, we see that g of f of a will be equal to the g of a. So the domain are equal, and at each element, the value of these functions are equal. So these functions are the same. In the end, we remark that two functions are equal if the domain are the same and for each element the image is the same. So there is no conditions about the codomain. By this remark, we finish our fifth video explaining these slides about functions.